हम्म हम्म हाँ, मतलब मैं ब्रॉडली बताऊंगा जी। जैसे फ्लड में क्या हुआ वो तो आपने बताना चाहिए किसी।
Hello and welcome to Down to Earth. I'm Snigdha Das. It's never easy to talk about disasters, about lives lost, families torn apart, homes, schools, and hospitals washed away, roads and highways cut off. Yet we must. Because for most of North India, this monsoon season brought nothing but one such disasters after another. Cloudbursts, extremely heavy rains, collapsing mountainsides, and devastating floods. A down-to-earth assessment shows that between June 1 and August 31, and this is just the first 3 months of the monsoon season, Uttarakhand, Himachal Pradesh, Jammu and Kashmir, and Ladakh experienced extreme rain events on 88 out of 92 days and recorded 506 deaths. And I must emphasize, these are conservative figures. In fact, the number of days during which these four states and union territories have experienced extreme events is higher than in any other monsoon season since 2022. A complete analysis of the situation is part of our special edition, New Climate, which is available on our website. So, what is behind this demonstration of nature's fury in northern India, particularly the western Himalayas? Is it climate change, human actions, or both? To discuss this, I am joined today by an eminent panel of scientists and experts. So let's welcome Dr. Kiran Han. He is Associate Professor in Tropical Meteorology at University of Reading in the UK and has done some great studies on Himalayan meteorology and the monsoon system. Welcome, Dr. Hunt. We have here with us Dr. Swapnamita Vaideswaran. She is Senior Scientist at the Wadia Institute of Himalayan Geology in Dehradun. She is an expert in remote sensing and satellite data and has been part of scientific teams that studied the Josimat sinking crisis and several similar disasters. I'm also joined today by Himanshu Thakkar, an engineer and expert on water-related issues, who currently serves as the coordinator of SANDRAP, the South Asia Network on Dams, Rivers, and People. I have here with me from my team Rajit Sengupta, who is Senior Assistant Editor with Down to Earth and has done some brilliant works on tracking changes in extreme weather events in India. Thank you all for joining today's discussion. We truly appreciate you taking the time to be here. I kindly request all the participants to share their questions in the Q&A box. We'll address them towards the end of the session. So let's begin the session. So Rajit, you have been closely tracking extreme weather events across India. Could you briefly show us how this monsoon season has been particularly unusual for North India?
Yes, thank you, Sigda. So I'll just quickly run through. So my name is Rajit Sengupta. Thanks a lot, Sigda, for handing over the space. So what we've been doing at Down to Earth is, like, since 2022, we've been looking at the number of days India is experiencing extreme weather events. So the metric that we're using is the number of days. So it does not tell you the frequency. It tells you the frequency, but it does not tell you the intensity. It does not tell you the widespread nature in a certain sense. So we are just monitoring the number of days to understand what is the frequency of extreme weather events. So we've been doing it since 2022. So this year, if we see even before the monsoon season, what our database shows is that it was unusual from the beginning. So rain-related extreme weather events, which are basically three extreme weather event types. So we are looking at lightning and storms. We're looking at cloudbursts. We're also looking at heavy rains, floods, and landslides. So these are the three extreme weather events that we track, rain-related. So what we found was that out of the 243 days, that is from January 1st till August 31st, on 97% of the days, some part of India was experiencing these extreme weather events. So that is something that we know, and this is perhaps the highest since 2022. So if you look at the graph on the left-hand side, the semi-circles that you see at the bottom, they tell you that. So in 2022, it was 68% from January till August 31st. Then 73% a year later, and 78%, and this time it was 97%. So it was unusually wet right from the beginning. Even though if you look at it, so IMD data shows that there were not surplus rainfalls throughout the months from January onwards, but there were freak rain-related extreme weather events that were recorded across the country through. What we also found is that there were unusually high numbers of deaths associated with these extreme weather events. So 3,502 deaths since January till August 31st, so which is roughly 14 deaths a day on an average for the entire country. And when we zoom into the monsoon months, what we see that trend continues in a way. And this monsoon, it was northwest which saw the worst in terms of the frequency. So what we have on the left is an IMD data, which basically talks about the district level surplus, so excess or large excess rainfall the districts that had experienced, and this is till September 6th. So this is for the monsoon period starting from June 1st till September 6th. So we found that there were 249 districts in India which had excess or large excess rainfall during this period, the first 3 months roughly of monsoons. And out of those 249, almost every second was in the northwest. So these districts were populated in the northwestern part of the country, in the northwestern states and union territories. Another way of looking at it is, out of the 208 districts within Northwest, 124 of those districts were cumulatively experiencing excess or large excess rainfall till September 6th. So we can look at this as well, how the Northwest was really vulnerable this year, and we can correlate it with the news that we have seen. What we also saw, and this is something of a trend that I'm confident the other experts will be able to explain better, is the fact that these rainfalls were also not throughout. So what we found was that there were certain weeks which were unusually wet, and they triggered the extreme weather events in a way. So if you look at, so over here, what we are looking at is we are looking at the week by week rainfall. So in the previous table, we looked at the cumulative from June till September 6th. Here we are looking at just weekly rainfall. So how much rainfall in that week the state usually receives, and how much did it receive in 2025 in that week. So that is what we're looking at. So in Jammu Kashmir, if you look at one of the northwest western union territories, there were 2 weeks, which you can see at the bottom, 260, that is the week ending August 27. That means from August 21 till August 27, it had received 260% more rainfall than what it should in that. A week later, that trend continues. It was 241% more. So if you look at it, till about August 13, there was a 10% cumulative rainfall deficit in Jammu and Kashmir. By the end of this week, so basically in a span of 1 month, the overall cumulative, it was 43% surplus because of these 2 weeks of insanely heavy rain. It's the same trend can be seen in Himachal Pradesh. In fact, Himachal Pradesh, you can see, so the dark blue colors show you the weeks which have received large excess rainfall, and the light blue color shows the excess rainfall. So you can see that there are 3 patches or 3 spells of extreme weather rainfall spells this monsoon. One was from June 26th to July 2nd. The other one was so in this period, Shimla and Mandi received really high. So that is not visible in the graph, but Shimla and Mandi districts received really high surplus, 482% and 433 in those 2 weeks. Then there was another in July 31st to August 6th, and the third spell was between August 14 and onwards. So till the time this magazine went to print, till September 6th. So August 14 till September 6th, that trend continued. Similar is the case with Uttarakhand. Uttarakhand, out of the 13 weeks in this 3 months that we're talking about, in 4 weeks, it had recorded excess or large excess rainfall. You can see the graph on the left as well. And finally, Punjab, a similar trend. So Punjab was also very interesting to look at. You can see that in the initial, the weeks were not that bad, except for the week ending July 2nd. And then towards the end, the last 2 weeks, August 27th and September 3rd ending, you can see that large surpluses that resulted in that disaster, which almost, in fact, all the districts of Punjab were flooded at the point in time. So that basically shows you how 2025 was unusually wet in terms of extreme weather events. Northwest during the monsoon period was excessively vulnerable, and within that, how different states and UTs received a lot of rainfall during specific weeks, and that led to the disasters. I'll just stop over here. Over to you, Snigdha.
Thank you. Thank you, Rajit. Okay. So I would like to bring in Dr. Swapnamita here. So you talked about these extreme rainfall events during the last few weeks, and that's when all the disasters happened in North India. And these are the weeks when we saw most of the cloudbursts and landslides. Dr. Swapnamita, cloudbursts and landslides are not new to the Himalayan states. But as a scientist, what stood out to you this year? What made this monsoon season and its rainfall events particularly unusual for you?
Hi, Snigdha. To talk about this events that has been happening, it is very surprising for several aspects. Number one, it started with the Dharali incident. It started around beginning of August. So 5th of August, we heard the Dharali. And we were thinking that probably, generally, we have just one such kind of disaster event. And then it started like a series. It just went on and on and on and on, and as if monsoon was just not finishing. And what stood out now, number one, is that we heard of places which we never heard of before, which experienced such kind of deluges. If you think about Dharali is on a very prominent route. And Dharali, in fact, we have some kind of background. We understood that there were deluges in the past. That whole fan probably must have formed in some past time. But then we got the news from Ghat, from Tharali, we got from Nandanagar. Then suddenly we very recently we got the whole Dehradun episode. Now, there initially we were thinking that we understand that rainfall can happen because of a orographic barrier, and this orographic barrier is like a height, and which causes the lift. And I think Dr. Hunt can speak much more about it, this entire system. But okay, now Dharali is beyond the main central thrust, which is Bhatwari is the main central thrust. And then we got Tharali, and this is between the MBT and the MCT, the main boundary thrust and the main central thrust. Then we suddenly got the entire Dehradun thing, which is between the Himalayan frontal thrust and the MBT, main boundary thrust. So you see there are different orographic heights, and there are different uh, places where we have a whole range where the whole climatic system actually affected this time. So this is something which stood out to me. And also the second thing which stood out is the whole thing happened within a short there was a short special variability. It affected very small special area, and just next to it or this side or that side there was nothing. Like in Dharali, we know that it extended from this place to this, and here there was nothing. There was nothing. Even in Dehradun, it affected from Vikasnagar to Saisdhara, and it just affected that area. So this short special variability of the flash floods, or let us call it intensive rainfall, because now they are so particular to not to quantify, because we don't have any weather stations there to quantify the data. So this intensive rainfall happened in this small particular zones. So these are two main things that stood out to me.
Thank you. That's interesting. So, what we are down to earth understand while doing our special edition on this is that the southwest monsoon has been quite active this year over the entire country. But the rains in the northwest parts of India got severe and intense by the presence of several additional factors. Moisture heavy winds were blowing from the Arabian Sea on the west, which deflected low pressure system originating from the Bay of Bengal towards north. And then there was the untimely presence of western disturbance over North India. Now, we all know that this western disturbance is crucial for winter rains and winter crops in North India. Usually, we see 4 to 6 western disturbances between December and March. They are rare during monsoon season. But this year, our assessment shows some 19 western disturbances hit the country between June 1 and the first week of September. Now, this is where I would like Dr. Hunt to elaborate this point. What is this Western disturbance? What is happening to it and why? Dr. Hunt.
Hi, thanks for having me. Yeah, so it's been a really, really unusual year, and it's been quite alarming to watch from afar. And every week here in Reading, we have these monsoon forecast meetings where we discuss the kind of weather that's going to turn up over the next week and try and understand some of the physics behind it. And a lot of the rain in the north this year has been really surprising. I mean, there's configurations of weather that effectively we haven't really seen before, and so it's given us a lot of food for thought. And there's a lot of research that needs to take place in this. Anyway, I'll discuss over the next sort of 10 minutes, I guess, a little bit about what we already know about Western disturbances, what we know about how they interact with the summer monsoon, and the possible roles that climate change plays in that relationship and how it might be changing that relationship. So just to kind of give a basic, you can see, hold on, if I do that, can you see my cursor if I do that?
Yeah.
Perfect. Excellent. So this is the kind of setup that we have. This is a nice schematic developed by a colleague of mine, Jean-Philippe Baudouin. And this shows you the kind of environment that the Western disturbances would encounter in the winter. So what you have, crucially, is this green band of air. This is the subtropical westerly jet. This is up in the upper levels, sort of around 10 to 15 kilometers plus. It's these strong westerly winds in which is usually embedded something cyclonic. That's basically winds that are turning anti-clockwise, a big trough in the upper levels. That's what we would call a Western disturbance, right? Typically, they originate somewhere between the Mediterranean or somewhere over Iran. Then they spin up quite quickly, and then they impact the Himalayas, which are here given in yellow. And what's crucial in the winter is that the subtropical jet, is really locked in place. And that's the thing that's bringing these Western disturbances into India. But it's locked in place basically through a combination of the Tibetan Plateau to the north, which is a sort of orographic anchor, but it's also a thermal anchor as well. It provides upper level temperature gradients that kind of lock the jet in place. And it doesn't really move that much in the winter months. Canonically then, in this kind of late spring, early summer months, so kind of around March, April, before the onset of the monsoon, the upper level thermal gradients change a bit in response to the seasons changing, and the jet tends to retreat northwards. It tends to retreat to the north of the Tibetan Plateau. Now, these Western disturbances are still rolling through the jet all of this time. It's just at this point, they're really too far north to have much consequence. And that's the kind of canonical picture. That's why you have Western disturbances in the winter, because the jet's there over India, over Pakistan, over the Himalayas. And then in the summer months, when it's moved to the north, okay, you may get some disturbances in the Karakoram or something, but they're quite unusual. This is what Western disturbances look like on the ground. So here I've tried to put together a kind of schematic that shows all of the kind of salient features. So Western disturbances, typically you think of them as this big blob of vorticity, swirling air in the upper levels. They can extend quite close to the surface. Obviously, they have surface impacts. And here they are embedded in that subtropical jet. Now, when they're in the jet, they produce this kind of wave structure in the jet. And to the right of the Western disturbance, sort of ahead of the Western disturbance, you get this accelerating passage of winds. That's what we call a jet streak. And dynamical theory tells us that associated with the jet streak, you usually get this, what we call ageostrophic ascent. So you get this region where you get this uplift of air. And now that's always true, basically ahead of a Western disturbance, because it's triggering these jet streaks. And so you get this ascending air. Now, when that ascending air is over, say, Mumbai or Delhi, what you get is basically kind of light thunderstorms, maybe a bit of drizzle or something. And when that when that blob of ascending air moves kind of towards the mountain regions, it gets intensified because the mountains kind of push all the air up, and you get it couples with what we call orographic ascent. So you get these two modes of ascending air associated with western disturbances: one kind of large scale, quite soft, and one kind of tight, heavy, deep ascent. And that's where you get your cloudbursts, your kind of big mesoscale convection, and all that stuff. And again, this is quite a winter picture. So western disturbances are quite strongly constrained, basically, in that they need to move close to the Arabian Sea because that's where their moisture is coming from. But if they're too far south, then you're not getting much impact in the mountains. So effectively, you need to, there's a kind of perfect latitude, if you like, where they're far enough south that they're getting that moisture in from the Arabian Sea, but not so far south that then they're not able to impact the mountains. And so it's finding that right latitude. Now, I talked a bit before about how the movement of the subtropical jet moves that latitude up and down, and that is reflected in the seasonality of western disturbances. So this is a frequency chart of WDs, if you like. And basically, I just want to point out that the peak months are sort of December to March. And then once you move into the monsoon, not only are they quite uncommon, July, August in the height of the monsoon, but they're also quite weak. We're getting a lot more blues, which indicates very weak western disturbances. However, the configurations in winter and summer are quite different. And the biggest difference between them is this, right? In the summer, you get this big, hot, wet mass of air sitting over India. That's the monsoonal air mass, the core monsoonal air mass. It's very humid, it's warm, and effectively it provides a much bigger pool of moisture for these western disturbances to interact with. In the winter, this area is dry. It might be warm, but it's usually a bit cooler, but crucially it's dry. So it has to extract that moisture from the Arabian Sea. And so this goes back to what I was talking about before. It's very sensitive. You need a strong western disturbance, and it needs to be right in the right position to extract that moisture from the Arabian Sea to create extreme rainfall events or extreme snowfall events. In the summer, that constraint is lost because you have this huge pool of moisture sitting over India. So basically, you can have a weaker western disturbance, or you can have one that's quite far north, and so it's not any longer constrained to be close to the Arabian Sea to produce high impact weather over the Himalayas. And that's what I've tried to show here. You still can get that moisture flux from the Arabian Sea, and that gives you a lot of convergence. And that's why often in the monsoon season, you get this moisture flux that swings up from the Arabian Sea, but then it hits already humid, wet air from the monsoon, and it can give you kind of strong rainfall over places like Chandigarh, like we saw a few years ago in July, that wouldn't usually get affected by winter western disturbances in that way. And so this is the key difference, basically. That's what I want you to take away, is that the constraints that are needed for a western disturbance to produce extreme weather are much weaker during the monsoon than in the winter. And therefore, if you get kind of any upper level disturbance that looks like a western disturbance, it's going to result in fairly catastrophic conditions on the ground. And this is something that we see in our forecast meetings. In the early months of the monsoon, particularly in June, if you get a rapid onset such that the monsoon has kind of covered the country by early July, and the subtropical jet has not yet retreated, then you find yourself in a position where you're really just waiting for catastrophe, because at some point the western disturbance is going to come along that jet, and it doesn't really matter what it looks like because there's so much moisture for it to interact with. You're going to get that extreme weather. And this is what that looks like in the monsoon. This is a slightly more technical slide. There's basically a bunch of different ways that western disturbances can interact with the monsoon. And I've set these up through kind of tropical depression type scenarios. So you have a tropical depression. That could just be an intense monsoon trough. It doesn't have to be a tropical depression or a low pressure system. It can just be a trough. But there's 4 different ways in which they can interact. And so, as I said before, the constraints on where that western disturbance is are massively weakened in terms of its ability to produce extreme rainfall. So one thing that can happen is that it can simply just combine with a tropical depression or the monsoon trough. That's what we saw in 2013 in Uttarakhand, basically, was a large monsoon trough almost kind of spun up a low pressure system, and that got underneath the western disturbance, and they combined in such a way that led to very extreme rainfall over Uttarakhand. There's also this mode that we call a jet streak excitation. So you remember I talked about how downstream of western disturbance you get this acceleration of the subtropical jet, and that gives you that ascending air that folds over that entrance region. Well, if you're underneath that entrance region and you've already got lots of very moist monsoonal air, you're going to get a big thunderstorm and you're going to get extreme rainfall. And that can result in very heavy rainfall in the central Himalayas as well as the western Himalayas. And this is one that's been fairly important over the last couple of years. And I think it's been the mode that's been really important this year, this kind of moisture exchange. So this is what I alluded to in the earlier slide, that basically, simply as the western disturbance turns up, it's just got a huge amount more moisture to interact with. And what we find is that typically in the summer, you can get precipitation amounts that are sort of 10 times higher than were there not that monsoonal air to interact with. So that's the setup, basically. That's why summer western disturbances are so much more scary as a prospect than the winter ones. The winter ones can give you extreme rainfall, but the summer ones almost always give you extreme rainfall. The question is, what is the role of climate change in all of this? And the answer, I'm afraid, is going to be quite disappointing. We don't really know that much, but I can point to some fairly recent research. Basically, what we do know is that the Tibetan Plateau is heating the atmosphere around it quicker than that atmosphere would be warming alone if the Tibetan Plateau were not there. Therefore, the atmosphere around the Tibetan Plateau is getting warmer than its surrounding, sort of compared to, say, over in the Zagros Mountains or up in Eurasia or something like that. That creates a hotspot. That's affecting and manipulating those upper level thermal gradients. Those temperature gradients that I mentioned are important for locking the jet in place. What happens is they lock the winter jet in place for longer now as a result of climate change, and we can show this quite easily. You see this here. That's what these red red colors and the black dots basically mean, that the jet is being held in place for longer. Typically, we would have expected it to migrate north March, April, May. Now it's staying through June, even into early July. And that's because of this. We can really attribute that to climate change. That's quite a strong signal. The result, therefore, is, as you might expect, you're getting more western disturbances reaching the monsoon. And I want you to look particularly here at May and June. So these colors basically show the frequency of western disturbances by year and by month. And basically in June, you previously weren't getting any western disturbances at all. And you can see in the last kind of 15 years, we've started to get several a month coming in. And it's the same for May as well. We've had an uptick in May and June of, I think it's gone up something like 5 times or 10 times. I can't remember the exact number, but a huge increase in western disturbances in May and June compared to even 30 years ago. So this is a very quick acceleration of their frequency. This was highlighted in a Hindustan Times article earlier this season, which showed this significant increase in western disturbances in June. However, what you'll see in this is that we do not get such a significant increase in western disturbances in, for example, July or August through this method. And this is effectively bringing us to the frontier of research. So we know the mechanism by which western disturbances are hanging around later in the winter season and incurring more and more into the kind of beginning of the monsoon. But as speakers before me have said, we've had them in July and August and even in September this year, which is extraordinary, really. I mean, it's the frequency that we've seen them and the level of impact they've had is really quite unprecedented. Now, we can't attribute that to climate change yet because it's 1 year and we don't really know why this year has been so weird. 2 theories, basically. One is maybe the jet has been holding back and we haven't really looked at that in a kind of detailed statistical level, but that might indicate that winter season is getting longer and longer and longer, and effectively the western disturbance season is getting later and later and later. Or a kind of slightly newer hypothesis is that there's a separate type of western disturbance that can emerge independently of the subtropical jet, so it doesn't matter where the subtropical jet is. And these come from effectively polar air masses, which have very high vorticity. They call them cut-off potential vorticity lows or cut-off lows, and they can migrate southwards. They're bigger, they're slower, and they're often stronger than traditional western disturbances, but there's very little research in those yet, so we don't really know whether they're responsible or what they're doing. What we do know about these cut-off lows is they are as common in summer as winter. There's not really a seasonality to them. And it may simply be that they're getting stronger and able to migrate further south into India than before. But this is definitely an area where more research is needed. So thank you for listening. I hope that all made sense.
Thank you. Quite insightful theories that you have, Dr. Hunt, and quite amazing work that you've been doing there to understand this complex weather system. So if I may summarize what Dr. Hunt just said in a few lines. So in our warming world, which is largely the result of human-induced emissions, the atmosphere holds more moisture, which is now being released in the form of intense rainfall events. Then what we are also seeing that the western disturbances are now becoming more frequent. The western disturbance season is getting longer. That's what Dr. Hunt said. And it is more frequent at the beginning of the monsoon season. And that is how it is colliding with the monsoon system, bringing in more rains. And it won't be wrong to say that their continued presence deep into the monsoon season this year is responsible for the disasters we saw in North India this time. This impact is probably going to be more severe in future, but we don't know. But should we place the blame solely on climate change for these kind of disasters that we see? Himanshuji, I would like to bring you in here. To what extent are human actions also responsible for the devastation that we see regularly see, and this time it was more severe in the Western Himalayas and in Punjab? And more importantly, what should we be doing going forward? What do we plan for a future that will likely bring more such extreme events? Himanshuji. You're on mute. If you can unmute yourself. Yeah.
Okay. Thank you very much for having me. And Dr. Hunt has very well explained how western disturbance is coming in at a delayed phase and interacting with the monsoon moisture and leading to the kind of situation we saw not only this year but last few years. However, we should remember there is an increasing tendency to escape responsibility by using these phrases like climate change, unprecedented rainfall, cloudbursts, etc. The first important point is the climate scientists have already forecast for many years back that there will be changes in temperatures, rainfall patterns, melting glaciers, gulfs, and we should be prepared for it. And they have also been predicting that there will be increasing frequency of high intensity rainfall. So we should again be ready for it. Also, we should remember that IMD had in each of the case of the western disturbance this season, IMD had warned in advance that it's going to happen. However, what we saw, there are a number of human actions which has worsened the disaster. If there is more rainfall, there will be more water in the landscape. Whether that more water turns into a flood and a disaster or not depends on how we deal with it. So, for example, one of the key factors we have been focusing at Sandrap is on how we are managing the dams like the Bakhara Pong and Ranjit Sagar in northern India. So, what we found is there has been serious mismanagement of these dams or dams operations, which has worsened the flood disaster rather than help moderate the floods which the dams were supposed to do. There was sufficient actionable information to warrant greater water releases in advance from these dams. These dams were also did not generate optimal hydropower. They generated suboptimal hydropower, which also led to greater water levels in the dams. And ultimately, the dams started releasing more water when Punjab faced floods, heavy rainfall, and worsening the flood disaster. Another factor which is very important, which is generally absent in public debate, is that our catchments areas are continuously degrading. The different basins, the catchment area degradation is a different pace, but the fact is they are all degrading. Degrading in the sense that it has the capacity of the catchment to hold, store, recharge, or drain the water is decreasing. And because of that, decreasing capacity, and this is happening largely because of the human interventions, largely thoughtless human interventions, which is leading to worsening the floods. What we are also seeing that in the name of development, we are worsening the disaster potential in the area due to increased landslides, erosion, silt generation, illegal dumping, and more importantly, projects being taken up through uninformed, non-transparent, unaccountable way without even a basic honest impact assessment. Leave aside any credible management plan or their monitoring and compliance. So these are some of the key factors which are leading to worsening of the actual disaster happening and worsening of it where it's already happening. We are also very weak. Most importantly, we are very weak in disaster management, preventive disaster management. We are possibly good in rescue and relief once the disaster happens, but there is a lot we can do in terms of preventing number of disasters or reducing the proportions of the disasters. And we are also very bad in formulating a standard operating procedures as to how are we going to deal with the disasters in terms of who is going to take prompt action, what action, and how is accountability going to flow from that. Coming to what future we can look at it and what we can do to reduce the disasters in future. One should remember that every dam has a rule curve. Rule curve means how the dam is supposed to be filled up during the monsoon. So every dam's updated rule curve and its daily inflow, outflow, storage, forecast of inflows, actual and forecast rainfall in the catchment, river flows in the catchment, situation of dams in the catchment, downstream river carrying capacity, and balance of the fact that there will be some rainfall in the downstream area which will need certain capacity. All of these factors are what will contribute to whether the floods happen or whether the disaster happens or not. And all of these factors should be in public domain for every dam on every day during the monsoon and should remain in the public domain for 5 years at least. These requirements should be mandated under the National Dam Safety Act so that it becomes a legally mandatory requirement. Secondly, all information related to the decision making about the dam operation should be in public domain. So not only the actual dam operation, but the information that is used to decide should also be in public domain. For example, the Bhakra BBMB chairman claimed in the press conference in Chandigarh first week of September that there was a technical committee which was taking decisions. But if it was taking decisions which was affecting the floods in the basin, that technical committee's agenda and minutes should be in public domain because that's a public interest issue. So that should be in public domain. Secondly, at the end of the monsoon, there should be a report from every dam as to how the dam was operated during the monsoon compared to the rule curve and otherwise. What were the issues it faced during the monsoon and how they were tackled. And we need to change what we need to change and learn for the future. So this kind of report should come out for every dam after the monsoon. Thirdly, rainfall reporting and forecasting must be done more basin and sub-basin wise. Today we have rainfall reporting done by IMD is mostly district and state wise. That's not very helpful in dealing with the floods. So the rainfall reporting and also rainfall forecasting should be more and more done basin and river basin and sub-basin wise. There is also need for independent assessment of IMD's reporting and forecasting. Because there are a lot of issues. IMD is a holy cow in India mostly. It's very highly respected. But there are very serious issues about the way IMD is both reporting and forecasting rainfall data. Similarly, there is a need for independent assessment of our national flood forecaster, Central Water Commission's flood forecasting work. That's also need because there is very shoddy work that they are doing. There is very little help they are providing in terms of dealing with the floods by accurately forecasting properly. So we actually need an independent agency for flood forecasting, considering the CWC's very poor track record. Next is at the end of the monsoon, there should be an independent assessment of the flood event. For example, taking into account who dams, institutions, what role they played, what problems were faced, who is to be held accountable, what lessons we can learn. And this should be required under, this kind of study should be required under Disaster Management Act. And this should be, this kind of independent assessment is required for every flood event during the monsoon. Because that's how we can really learn from the disasters and learn for the future and how we are going to improve our disaster management. Similarly, disaster preparedness is very important, and that should be assessed through a Disaster Management Act before every monsoon. For every state, every river basin, every large dam or embankment, and every city. Because these will help us again, improve on our preparedness about disaster management. Next is there should be an assessment of health of river catchments. I mentioned about the degradation of catchment. Now that health of the river catchment should be a process of continuous assessment. So what is the health of the river catchment and river basin, sub-basin, and what is its capacity to hold, store, recharge, or drain rainwater, and how that capacity is changing, and how does it compare with the actual rainfall that is happening, that the state has to, or the river basin has to deal with. So these how the various development interventions are changing this catchment health, and how their impact can be monitored, reduced, and mitigated. All these aspects should be part of the EIA, EMP, monitoring and compliance, and the project managers must be held accountable for violations. And of course, we know we have a long way to go in each of these aspects. The EIA, EMP, monitoring, compliance, practically non-existent today. Next is we need a national silt management policy and an action plan, because as we see that it's what the flood converted into disaster, a major factor was silt. It was not just water that was flowing. It was very heavily silt-laden water. Now, where does this so much silt coming from? So, and what is our silt management policy? So our reservoirs are getting silted up. Our riverbeds are getting silted up. Both are losing the capacity to manage floods. Rivers are losing capacity to, carrying capacity to carry floods. Now, all of this, are related to silt management. So we need a national silt management policy and action plan. This needs to be urgently formulated, implemented. So, and key thing is that once the silt enters the reservoirs and rivers, it's very economically unviable to take that large quantity of silt from the rivers or reservoirs and take it far from long distances. We have not found it feasible anywhere. So what is important is that we need to minimize the entry of silt into the rivers and reservoirs through management of the catchment, through having more forest, natural forests, more local water bodies, and number of other ways. And all this should flow from the policy and action plan about the silt management, particularly keeping in mind the state of the rivers and reservoirs. And for Himalayan states, National Disaster Management Authority in October 2020 came out with the GLOF guidelines. Now, GLOF are going to be increasingly reality of our floods, the kind of floods we are going to face in Himalayan states. But that, unfortunately, those guidelines, 5 years after they were published, are just sitting there there's no implementation. In fact, if those guidelines were implemented, for example, in Darali, then there should have been no habitation in that fan area at all. And that in 5 years was sufficient time to prepare a plan to remove all such risky habitations. So this NDMA's GLOF guidelines needs to be urgently implemented through a time-bound action plan, and this should possibly again mandated under the Disaster Management Act. So these are some of the key things that we can do to better forecast, better be better informed, be better prepared, and be better able to manage the floods and disasters. Thank you.
Thank you, Himanshuji. Quite important suggestions that you have made here. I recently had a conversation with Dr. Swapnamita, where she also shared some important perspectives that while these large hydropower plants and the national highways are often blamed for the kind of disasters we see in the Himalayas, they may not be always responsible. Through her extensive fieldwork and travel, she has observed several lesser known but significant factors contributing to the risk. Now, Sapnapita, can you please elaborate on this point?
To come to that point, can I go a little bit into the different disasters, how we look at
Please.
it
Yeah,
geologically?
please.
I'm sharing my screen. So let us start from Dharali, because that is what we saw initially. And okay, if you see Dharali, Dharali was actually already at risk. And Dharali is situated on an alluvial fan, and all these things we know already. We have talked about it so much. And if this is Dharali, and what we saw this time was that this entire, can you see my screen?
Yeah, yeah. Yes.
So we saw this entire market of Dharali was completely destroyed. But of course, we have also heard that by now we know that this has had deluges in the past. And this deluge has, in fact, buried the Kalkedar temple in the past, which was dug out in the beginning of the 90s. So all these things we know, and we make mistakes again and again. And now, what we saw in Dharali is that can you see Harsil here? So
Yeah.
Harsil is a valley. It's in the valley, in the Bhagirathi Valley. And what happened in Dharali happened actually on the top, above 4,000 meters, and everything came down. And we have got weather stations now. We have weather stations in the valleys or near prominent prominent glaciers. So if supposing there are some important glaciers we are studying, we have got weather stations there. But what we understood in the whole Dharali incident is that now I was talking about the short spatial variability. So the weather stations not being there in a very dense network actually affected our entire understanding of the phenomena that caused the Dharali incident. And of course, Dharali did not happen only in Dharali; it was in an extended area, and we did not know how to, understand what was causing from the top in how much spatial extent. So all those things were lacking because of the missing instrumentation, and we did not understand that we need more densely spaced weather stations. So that is where I wanted to point out about Dharali. That what is that we are lacking in our studies. We are lacking high resolution maps, we are lacking high resolution risk maps. And if supposing we say that we have susceptibility maps, but at what scale? So do we need to now rescale our studies and then bring it into resolutions that we can actually, it is for implementation and for the decision makers. Because the research that we do, if it is not the decision makers cannot implement on the ground, then that kind of research is actually now becoming very obsolete research. So we want to now give research which can be implemented on the ground. For that we need high resolution maps. And this is something that I always keep on saying, that our survey of India topographies are excellent. They have been done, it becomes a base for all our studies. But the scale and the resolution is actually not enough now, because now we are looking at this kind of disasters happening, and too many and everywhere. And we now need to understand how we can get into a higher scale. For that we need very good lidar mapping, and we need good topographic maps at a very high resolution. And now we need to also increase our instrumentation, in the sense that we need more weather stations. And I was again talking about Dharali, and I showed you the where is Harsil, and I showed you that we did not have weather stations up here, and we had weather stations down here. So initially, when Dharali happened, everybody kept on saying that we there was only 8 mm rainfall, and how can it be a cloudburst? And we cannot. It was not a cloudburst. And most of the time, we kept on thinking that we cannot. We do not know the cause of Dharali. So ultimately, when we went to field, we saw signatures out there, and we saw what kind of intensive rainfall has happened at altitudes where in the valley, we actually in Harsil, we do not expect torrential or intensive rainfall. We expect only drizzles up in the mountains. And we have got such kind of torrential rainfall up at elevations above 4,000, and our snow line is about 2,500 in the Himalayas, but our permanent snow line is about like 4,800 or 4,500 meters. And at regions where we have a permanent snow line, it did not snow, but there was torrential rainfall. So these are things that are changing, and now we need to also understand how we need to now bring our data together to understand how we now understand these kind of changes and now remodel our entire research. So I wanted to talk to you about a little bit about Dharali. Okay, let me again share my screen. um, See, in Dharali, when we had can you see my screen?
Yeah.
So Dharali, again, it was the short spatial variability. Again, what I said affected this area, did not affect this, and did not affect this. So you understand what kind of close space it was working on this entire event. And see, this is about 3,500, above 3,500. And when we went to field, there were such kind of real erosion which showed that there was surface flows. There was not only flows on the nalas which brought down the deluge, but there were surface flows which completely smashed the ground. So you understand now that there were very intensive rainfall. And if someone says that there was, everything came from the moraine, everything did not come from the moraine area, from the glacier area, because we have data from there also. And we saw that what has happened actually because of this very high water flow. So in the glaciers, let me show you this. On the left, I have got this data, which is 2014, 2017, and 2025, the data we collected. So we thought that this moraine bridge, or the entire material came down from the moraine, and morainic material and the glacier terrain, but there was already glaciofluvial erosion there from all these years. And this time, only thing that we saw was a little more exposed, that recessional moraine, which exposed ice inside. And what we saw on the nalas were very constricted nalas, very, very constricted, where damming has happened at multiple places. And these dams, and also this whole water, the intensity of the water was scouring these nalas and were causing several landslides on its path. And they were causing dams, and these dams breach time to time. And this breaching of the dams, what it did was, it created number of deluges. So you saw in Dharali, you must have heard that there were 6 episodes of major deluges coming down, and deluge after deluge, and ultimately it covered the entire Dharali, that alluvial fan. So this happened because there was damming, and these dams breached time to time. So you see, until and unless we have very good field data, our satellite data is actually not sufficient to give us the complete picture of these disasters. Then, if you want to understand about Dehradun, what we saw is that it happened from, supposing from the west, you take. Let me show you on the Google map. So on the west you have got Sahasdhara, and on the east you have got Vikasnagar. And sorry, so on the east you have got my north is south and south is north. Would you like to see it like that? Anyway, it doesn't matter. I want to show north as south so that you understand the topography here. Can you see a 3D image here?
No.
No? A little bit of 3D feeling from the Google Earth?
You're not able to share your screen, so can you?
Acha, okay. I will share it again. Yeah, can you see now?
Yeah.
Okay. So what happened in Dehradun happened from this Kaligad. There is a Gad means a mountain stream, a rivulet. So it happened from Kaligad, and it continued up till almost like below Bhadra's temple, which is around Vikasnagar and Suddhowala side. So what we saw was that this entire line was affected. So what happened? Everything came down from the top here and it flowed down. And through all these small guards, which actually are rivers in the Dune area. So the whole Dune Valley is dissected by these rivers which are coming down from the Masuri Hills and from the Mohand, from the HFT and the MBT that I was talking about. And in the Kaligad, where everything started, it affected the entire Sehasthara, this area, the market and the whole shops and the tourist places. And then it flowed down all these nalas and the drains. And nala actually doesn't mean a drain. Nala is actually a rivulet or a mountain stream, you know.
Yeah.
And now there is so much of construction out here, and these rivers want to meander along with time. And we have now confined them into spaces which has actually intensified its flow. It is amounting to scouring, it is amounting to more erosion, it is also amounting to deposition of more material. And if we touch these rivers, then we are actually tampering with the river morphometry, which in turn will cause such kind of harms. Initially probably we do not understand this harm, but then later on it is so harmful, these hazards are beyond repair. So now if the nalas are coming down like this, an entire episode what has happened in Dehradun area has happened down from that line that you saw just now. And this is something that we did not expect. We did not expect that. And it did not touch Masuri. Okay, it everything happened just below Masuri from this entire Bhadraj temple, and it's in a linear line. So the whole rainfall phenomena happened in a linear trend, and it all came down from east and west down to Dehradun. And if supposing these nalas had their free parts, then probably they would have carried this water. But these nalas are now so confined with either encroachment, or we have understood that we have constructed on the floodplain. And this is something that I am really worried about. And this is why we need very high resolution data. And LiDAR gives us the bare earth without any built up, without any forest, so that we understand where the topographic slope is, because water flows according to gradient. Even a 1 degree gradient is very important for water. So as to plan, we need now this base data, and this base data is going to give us a good resolution risk map. And this is where we need to look at. We need to now look at which are the risk map, because according to what Dr. Hunt has said, that now we should be more prepared to expect more this kind of rainfall patterns. And we have also understood when we plotted 100 years of data that yes, precipitation is decreasing over years, but then concentrated precipitation in the form of extreme weather is also increasing. So this is something that we need to be prepared now. I would like to talk about a model. It's Hong Kong model, and it is called the Hong Kong model because Hong Kong, initiated and established this model very well. And what has happened in the Hong Kong model is that they have established, and of course, we now understand that rainfall is playing a very big part. Apart from the geology, so the weather, the climatology is also very, very important. So the Hong Kong model employs a lot of weather stations, a lot of early warning systems, and I will not accept it if somebody says that early warning systems doesn't work. There are methods in which early warning systems need to be established. So, Hong Kong has established a lot of early warning systems and a lot of meteorological stations. And these meteorological stations probably are smart stations for them. They get the data instantaneously and they work on a near real time. But if supposing for us in India, we cannot have such kind of very high investment. We can definitely install a lot of ordinary rain gauges all over to bring a very dense instrumentation, and these are ordinary rain gauges, and what we need there is to probably keep them wherever we can in schools and colleges, train the students to contribute in giving the data, collecting it in real time, and probably sending it across to researchers. And where we have got no schools and colleges, like in elevated areas where Dharali incident happened, we have got, in Dharali, in elevations up there, we had a lot of shepherds. We spoke to them, we understood everything from them, the whole timeline and what happened and where what happened, what. So we have community support which we can utilize, and we can initiate with this ordinary rain gauges to bring a very close network of stations to understand the climate variability. And also the Hong Kong model then goes on to create a kind of a medical report, on all the risk areas that they have identified. And what they do is they continuously monitor, they have the whole geology completely done. So the rock type, the geotechnical aspects, everything. If supposing they are expecting a landslide, so on what slip plane it may occur, then all these things are already there. Plus, what they have is at any point of time, if any kind of mitigation measure has been implemented, that will also be in the record. Which year, what kind. So you see, they are maintaining a record. And in that way, and now another thing that we don't have is we do not have a very long foresight. We are not looking at a very long distance, and we are not prepared for that reason. We are very close sighted. And of course, hindsight is our favorite thing, because whenever some disaster happens, everybody goes, reaches there and works on that disaster. Like everybody reached Joshimat, and now we have so many things in Joshimat. But what about understanding from Joshimat and understanding where else? Because tomorrow a similar Joshimat might surprise us. So what are we doing to understand the different areas in our mountain states, and getting prepared? Also, another thing about early warning system. So there are instrument based early warning systems also, like installing piezometers and inclinometers and tilt meters. These are expensive, so everywhere we do not go for such kind of installation, but we do such kind of installation when there is a big community at risk, lives at risk, or some major infrastructure at risk. So yes, we can go for such kind of early warning system. But what happens when you have early warning systems in any form, whether there are ordinary systems or very scientific systems? It gives a bit of confidence to the community, and this is also part of preparedness. On their mind, they have this feeling that we have the early warning system, and they also become aware, and slowly it builds a mentality that this place is already at risk. So the whole mindset to expand a place beyond its capacity actually is curtailed by such early warning systems, because it tells the people that here there is a risk, we are already monitoring you, so you do not expand here. So that slowly, they are prepared to actually move out of that place, rather than giving a shock and some disaster happens and then we rehabilitate people. So all these things are on my mind, and this is what probably this entire series after series of disasters that have come up upon us this time is bringing to us.
Thank you.
Is
Thank
there?
you.
Yes.
It's quite insightful talk that you had. So, as the climate changes, basically the character of extreme weather events is also shifting, and that's why we need to prepare for this eventuality. And hence, there is a need for better infrastructure, warning system, instrumentation, and also transparency that Himanshuji mentioned. So we are now nearing the end of our session, and I see we have some interesting questions from the audience, but I'd like to take one particular question by just this by Dipali's Semwal. So Dipali's question is, given the change in the amount of rainfall, would it make living certain mountain areas infeasible in the future and leading people to migrate? Should we look into transformative adaptation for these regions and in general? So I would like Himanshu ji to respond to this question, and also Swapnamita, if you can respond to this. Because this is, I'm pretty sure this is what is going on in most people's mind these days after what we saw in the Himalayan states and this time.
I think we need to make informed decisions. So first thing is that we need to identify the vulnerable areas. Now, Dharali, if you look at the precedent, was clearly at risk village, a habitat. And so all those buildings in the fan area shouldn't have been there. And that's what the GLOF guidelines of 2020 also says. But nothing was done to remove them. So what we need is, we have a lot of things. So, there are areas or villages and habitations which are at risk because of landslides. There are some because of the floods. There are some at risk because of the GLOFs. So there are different vulnerabilities are there. For in Lahul Spiti area, there are some villages which are sinking actually, and sinking not because of heavy rainfall or erosion, but because when there is a high temperatures, they start sinking. So there are different vulnerabilities in different areas. We need to identify those and prepare a time-bound action plan to firstly not only not have any intervention in those areas. Now in Lahul Spiti area, some of those vulnerable areas, they are planning to build hydropower projects and tunnels. I mean, that's complete mindless thing to do, but that's what is going on. So we need to identify such areas, vulnerable areas, firstly to ensure that there are no expansions, and where there are areas, habitations which are already at risk, they needs to be removed in time bound manner. This was stated even after June 2013 Uttarakhand disaster, which was a massive disaster. Thousands of people died. But what did we do after that? Nothing. In terms of taking precautions, so that this, and in fact, people at that time had said, people of Uttarakhand after June 2000 had said, ये तो अभी ट्रेलर है, फिल्म अभी बाकी है. This is what they had said, and we had written about that. And that's what is happening now. Even
Yes.
now, what we are saying is possibly trailers, and much more bigger things are going to happen. So we need to have identify such locations, make them safe, remove them, and even hydropower projects and dams. Again, we need to be very cautious. We are not doing even proper EIA of hydropower projects. And Down to Earth and Central for Science and Environment should be highlighting this aspect, that how are we taking the developmental projects,
So,
hydropower projects, even roads, railways, urban cities. All of these are coming up. Lot of them are coming up without honest environment impact assessment, without honest social impact assessment. In fact, what we have been saying at Sandra for many years is that these projects in Himalayas also need disaster impact assessment. What does it mean?
your comment, please, on the issue on.
Yeah. So disaster impact assessment means that the area is already vulnerable to disasters, and how that is going to change because of that. So basically, I agree with the question, and that we need to identify such locations and remove them, and this we need to keep in mind with whatever development interventions we take up in Himalayas or elsewhere.
Thank you. Thank you, Himanshu ji. Swapnamita, please.
Yes. I would like to first point out, which I have been telling again and again, definitely we have a much, sinister kind of thing, that we are not considering the population of the country, and we are doing nothing about it. So I feel that if supposing we have population like this, they have to live somewhere. So a lot of places are occupied because of this overpopulation. Otherwise, where are they going to live? So number one thing, I don't want to get too much into it, but coming to hydropower dams, I feel that a lot of good projects have got very good DPRs. I have seen the NTPC project because I have been working in Joshimath from 2006. I was with the Uttarakhand disaster management then, And 2006, the project had not even started. And the Joshimat slope was already experiencing landslide. And I do not call it subsidence, I do not call it sinking. I definitely call it landslide because it is a landslide. And this is controlled geologically. We know now that it is a deep seated landslide. Now the thing is that now we try to come into one area and we make these mountain towns grow into mountain big cities beyond its capacity is something that I have been unable to fathom. Because there is a place called Dhak, which is like about 4 kilometers from Joshimat town, and people have actually moved from there and they have come and built their houses. The houses are so close together. This Manohar Bagh and the Singhdar area is a very, very densely populated area in Joshimat. And people want to live in one place. Now, I think from the government side, there can be definitely such kind of, planning that very important facilities like healthcare, like schools, should be provided even to villages and towns. And should be, every place should have these basic facilities so that people don't have to come and settle there along with their families. Well, there are certain places which are business people places, and well, you cannot expect that every town and every village will become a business place. But also people are shifting from agriculture to tourism. So are there enough incentives from the government to the villagers, or they are understanding why this shifting is happening? So we need to diversify the occupation of people. And also, I think this towns growing beyond the capacity is something that we need to look at. And we are expanding roads and we are expanding our bridges, or we are taking elevated roads over rivers. And all these things, like Dehradun is right now, there are a lot of discussions and arguments going on that will should there be elevated roads on the rivers, which I feel that it has to be looked at. Because I don't think so that this much of road expansion is required. What is required is, are you providing enough public transportation to people so that in one vehicle most of the public can travel easily, so that you reduce the congestion of the places. And then also, tourists, I think our tourism industry is definitely very skewed in the form that there are less high value tourists, and there are high number. There is no we need less number but high value of tourism. And we do not need to change the places according to the tourists who are coming, because tourists should go and see places for what they are. This is something that I don't know why the places change according to the tourist requirements. Then also, for tunnels, all the tunnels happening, especially in these mountain towns. Well, I feel that of late I have been definitely seeing some tunnels being built without proper DPRs. And here we need to have very strict policies where there is a good technical team before the projects are sanctioned, who goes through DPRs and see whether they are scientifically feasible DPRs or not. Then another thing that I feel is lacking in us is that we try to also uh, we do not do good waste management, and we do not have proper drainage, proper this sewer systems. And also, last one thing, our projects do not end on time. So our projects need to end on time, and there has to be a strict implementation time so that the environment and the ecology doesn't suffer. Extended project time always cause harm to the environment. So especially I spoke to you, Snigdha, about the Prime Minister Gram Sadak Yojana roads. So those are overlooked. We do not, nobody talks about, they talk about the highways, but they do not talk about these roads which are happening everywhere, and who is actually giving the technical input for these roads to go where they are going. So all these things are things that we need to now look at to be better prepared.
Very important points, Dr. Supramita. Like, definitely, we don't need to change the mountains to make them the plains, and then we need a different model, economic model for such an eco-sensitive region. So before we wrap up, I'd like Dr. Hunt for his quick closing remarks on this. Dr. Hunt, are you still there? Yeah.
I am still here, yes. It's very hard to follow up on all of that stuff, particularly as I have very, very little expertise in the kind of impact level of stuff. But there have been a couple of points that have been raised a few times, and this is the idea of better observations, better models, and those are the kind of necessary ingredients for better on-the-ground warnings. The Himalayas has always been a region where observations are extremely difficult to get. And even with satellites, we were never able to really drill down because satellites get a lot of ground clutter from the mountains and all that kind of stuff. And, you know, even if you go to the great expense of putting gauges out there, rain gauges, you end up with very sharp gradients in that rainfall because of the valleys, and they're difficult to maintain because you have to go back and sort them out. This is a problem that's going to persist for a long time. And so we need to think about ways in which we can, you know, effectively what we have to do is start to rely more and more on the models, right? Because the observations are just never going to be at a state where we can, you know, where we can use them reliably, because it's just too difficult to observe at this point, I think, until we have some significant breakthrough in satellites or radar technology or something. So what we need from the models is high resolution, because you need to be able to resolve the mountains to make sure that you're getting the intensities right because of all of these orographic effects that come in. And you know, IMD has made some really good strides in that. We've had this 6-kilometer global model that's come out recently, the Parat model, and you know, that looks really promising. But I think there needs to be an increasing focus on these regional models, these very high resolution regional models. We can tell in advance, as other people have said, and as we kind of all know, you know, you can tell in advance when one of these systems is coming, right? It's not like you're on Tuesday and there's nothing, and then Wednesday suddenly there's a western disturbance right above you. You can see it coming. So the idea of like a targeted regional model where you can, you know, 5 days in advance, you know, a western disturbance is coming. It's the summer, you know, you're going to get some really heavy precipitation somewhere. To get a very high resolution model over the region that your kind of broader, coarser models are predicting, and to really drill down and get an idea of where the high impacts are likely to be, I think is probably the best method that we have given where we are at the moment. And you know, other places have used this quite successfully, and I think it would have a lot of potentially quite positive impact here. And this, of course, is long before we move into the region of climate mitigation, climate adaptation, or anything like that. But just thinking about what could we do, you know, in the next few months that could make a difference, I think it would be something like that. But like I said, people know a lot more about this kind of stuff than me. I'm just a weather theorist, you know.
But that's important. That's great. Even though US President Trump claims that climate change is the greatest con job, we definitely see climate change impacts unfolding right before our eyes. I truly hope that today's insightful discussion, along with the work we continue to do here at Down to Earth, will serve as a strong nudge to our policymakers and stakeholders to take meaningful and urgent action. Thank you all, and good day.
Thank you. Bye-bye. It was a very good discussion.
Loved it. Thank you.
Thank you.
Thank you. Yeah, nice to hear so many different points of view.
Yes, same here.
Take care. Bye-bye.